Hello guys, I'm Dekmar. This video going to say about implementing dynamic programming solution to find optimal path for traveling salesman program. So the actual problem is the salesman will travel from one city to another city. So you have to find a shortest possible route with the minimum possible cost. So that we're using a dynamic programming solution here. So now we go to the code. So first declaring a class as TSP and declaring a function as get cost. Then next declaring a function as calculate. So now see the class and class name as TSP. Then def init of self comma m. Then self dot m equal to m. Then using a function and a def and get cost of self comma r comma c comma source. If c equal to 0, then return self dot m of source comma r source r comma source. Then it will return a self dot m of r comma c. Then again using a function called def and function and calculate of self comma destination comma source comma node. Then if you are using a if statement, if length of nodes equal to n, then minimum cost equal to self dot get cost of source comma node of 0 comma destination plus self dot get cost of node of 0 comma dest. Then it will return a minimum cost. Else it will go for cost list equal to list. You're using list function list. Next for loop we are using here for n in nodes t nodes equal to nodes of colon. Then t nodes will remove the n. So then cost list will append. So cost list dot append of self dot get cost of source comma n comma source. Then plus self dot calculate of destination comma n comma t nodes. Then cost will append. So cost dot append of cost list. Then it will return a minimum of cost list. Then we're going to get a input for vertices. So n equal to input of enter the number of vertices. Then m. Then using a for loop here. So for I in range of n comma for one comma n plus 1. Then for j in range of 1 comma n plus 1. Here I will be the row and j will be the column. If I equal to j, then m of I comma j will be the 0. Else it will enter the cost from I to j. Then it will get input for the cost. After that you're going to get you're going to find the shortest path. So getting input for that, so v equal to int of input of enter the vertex to find the shortest path for. Then we declaring nodes. If and I'm using for the for loop here for I in range of 1 comma n plus 1, and if I equal to b, it will continue, else it will nodes will append. Then TSP equal to TSP of m, then it will calculate the minimum possible cost. Now we run the program. So now it's asking for the enter the number of vertices. We're going to give a number of vertices as 3. So it's asking enter the number of cost from one place to route 1 to route 2. We're going to give cost as 10. Now it's asking enter the cost from route 1 to route 3. So we're going to give cost as 15. Now it's asking enter the cost from route 2 to route 1. So we're going to give a cost as 20. So now it's asking enter the cost from route 2 to route 3. So going to cost as 25. So now it's asking for enter the cost from route 3 to route 1. I'm going to give a cost as 30. So now it's asking enter the cost from route 3 to route 2. I'm going to give cost as 35. So it's asking now enter the vertex to find the shortest path for. I'm going to give a vertex as 1. Then the output minimum possible cost is 65. That's all, guys. This is the dynamic programming solution to find a optimal path for traveling salesman program. That's all, guys. Thanks for watching.